This time we look at how the carrier evolved from World War II. With dramatic advancement in air power and aircraft performance, dramatic changes needed to be made to the carrier for it to be a workable and efficient platform. We check out how rocketry and aviation are used in sea power. The ballistic missile is one of the deadliest weapons ever built. We take a look at the progression of these missiles as well as the Tomahawk. Lastly, we focus on the early Corsair from the Vought company. It was one of the most versatile fighters of World War II and is one of the pinnacles of propeller-driven fighter aircraft. During World War II, two carrier groups met in the Coral Sea, and this was the first battle that was entirely fought with naval air power. The incident was fought by American and Japanese carriers, and it was this battle that proved the worth of the carrier. Today, the most powerful naval force is the carrier group, and only a few countries in the world have such battle fleets. Although the vessels themselves have great firepower, it is the air power that the actual carrier supplies that make the carrier group an ideal offensive and standoff asset. The dawning of the jet age and the steam-powered catapult saw many new ventures onto the carrier deck. Some of the most notable were the Crusader from Vought, the A4D Skyhawk by Douglas, and the Corsair II, also from Vought in the attack role. The Corsairs in particular went into service with the Marines as well and became celebrated in the era of Vietnam. Meanwhile, the Navy's jet fighter development came to the force with McDonnell's F-4 Phantom. The plane, which was first delivered in 1958, saw many appearances in various conflicts. Remarkably, the last F-4 rolled out of the factory in 1979. Today, it is being considered for new roles after maintenance and upgrading by the European Aeronautic Defence and Space Company. The plane is still providing service, though little of the original 50-year-old design remains unchanged. Regardless of the initial engine problems, the Tomcat was revolutionary and the pinnacle of what had been learned from the early beginnings of building carrier-based aircraft. The difficulty with the advancement of carrier-based planes was that every step forward in aviation required changes to the actual carrier. With the development of the jet engine rose substantial problems. Jet aircraft were getting heavier and heavier with every new model. They also got much faster. This meant that their landing and takeoff speeds were higher and they required longer runways. Major changes to the aircraft carrier's shape and the procedures of pilots and ground crew were required for the jet age. With their weight exceeding 10,000 pounds and their high landing speeds, crash barriers were not always sufficient to prevent accidents such as this. In the late 1940s, there was a huge increase in accidents involving planes slamming into parked aircraft. To overcome this, the angled deck was employed. The angled deck runway permitted pilots who missed the trap wires to accelerate and go round again. This improvement also freed up the deck space to allow more planes to be flight ready or prepared. The steam catapult was another addition that assisted the plane to achieve takeoff speed over a very short distance. An F-14 requires about 1 mile of runway to lift off. On a carrier, this 30-ton plane is catapulted to 170 miles per hour in 3 seconds over a distance of 300 feet. Although these carrier features were employed before the Tomcat's arrival, it is interesting to note that the Tomcat was built to excel all other aircraft, and it had to be created within the limitations of that day's carriers. The plane, first delivered in 1972, became the mainstay of the carrier strike force. With its variable wing geometry and diverse payload capabilities, was top gun for an extensive period. However, the Tomcat is now in its final years of Navy service, being pressed into the reconnaissance and bombcat strike roles. During this period, the attack role was taken up by the FA-18 Hornet from Boeing and McDonnell Douglas. The Tomcat's replacement will probably be the new F-18F Super Hornet, a longer twin-seat version of the existing Hornets. The FA-18 Hornet had originally been ordered as a dual-role fighter and attack aircraft, intended to replace the Vought A-7 Corsair II, the A-6 Intruder, and the McDonnell F-4 Phantom in Navy service, and to augment the significantly more costly Grumman F-14 Tomcat. The first operational cruise by Navy Hornet squadrons took place in February to August 1985, deploying aboard the USS Constellation. Today, the Hornet and the aging F-14s are the current fighter and attack aircraft on most US carriers. Firing missiles from planes has always had problems. One of the major problems is the performance of the plane's jet engines when they are caught in the hot exhaust gas of the released missile. Temperature gradients of up to 6,000 degrees Celsius a second can be realized when a missile is fired from an aircraft, and this can severely hamper the aircraft's jets. This is a Eurofighter. When a Eurofighter climbs into the sky, it takes a load of high technology aloft. Its two EJ-200 engines give the strike aircraft breathtaking agility and speed. EJ-200s are totally reliable, even when they're caught in the hot exhaust jet of a missile just fired. In a first for a European company, MTU Aero Engines has managed to simulate that situation on the ground, which saves customers much money. MTU's engineers have conceived an innovative test setup to simulate the temperature profiles and gradients involved in missile firing. At the heart of the test arrangement was a specially fabricated hydrogen burner installed in the front of the intake of an EJ-200 production engine at a Munich test stand. The results of over 100 test units witnessed that the EJ-200 proved superbly stable and tolerant of the exhaust gas temperature profiles of rocket engines. An impinging hot exhaust jet puts engines under formidable stress. The searing temperatures may cause an abrupt compressor stall, with the air no longer passing through the engine but being forced in the opposite direction, and the notorious engine surge condition occurs. If the condition is bad enough, a blowout in the combustor results and the engine dies. If it doesn't recover, the pilot has to try and relight it. Previous tests were done in the air. Now they can be simulated in safety and in controlled conditions on the ground. The Eurofighter is the first aircraft to have such an evaluation on its performance while firing missiles, and this has saved the military millions of dollars. Perhaps one of the deadliest missiles ever built is launched from under the sea. This is a ballistic missile submarine. These submarines were first deployed by the US Navy during 1960 and were armed with the Polaris intercontinental missile, and later the Poseidon. The latest version of this type of weapon is the Trident. The Trident missile is an intercontinental ballistic missile, or ICBM, and is armed with nuclear warheads. The Trident was built in two variants. The one, C4 UGM-93A, and two, D5 UGM-133A. The C4 and D5 designations put the missiles within the family that started in 1960, with Polaris A1, A2 and A3, and continued with the 1971 Poseidon C3. Ideally, the missile is sheathed in gas bubbles for its entire time in the water, so liquid never touches its fuselage. The launch from the submarine occurs below the ocean surface. The missiles are ejected from their tubes by gas pressure created by a gas generator, a solid fuel rocket motor attached to the bottom of the missile tube and exhausting into it. Both Trident versions are three-stage solid propellant inertially guided missiles, whose range is increased by an aerospike, a telescoping outward extension that halves frontal drag. After the missile leaves the tube and rises through the water over the submarine, the first stage motor ignites, the aerospike extends, and the boost stage begins. The Trident is carried by 14 active US Ohio-class submarines and 4 UK Vanguard-class submarines. The Tomahawk land attack missile is a long-range, all-weather subsonic cruise missile with stubby wings. Introduced by General Dynamics in the 1970s, it was designed as a medium to long-range, low-altitude missile that could be launched from a submerged submarine. It has been improved several times and is now made by Raytheon. There have been several variants employing several kinds of warheads. The operational versions include the unitary conventional land attack, TLAM-C, the bomblet dispensing land attack, TLAM-D, and the nuclear land attack, TLAM-A and TLAM-N. There is also the Tomahawk anti-ship missile, TASM. By far the biggest improvement is making the Tomahawk network-centric warfare capable, using data from its multiple sensors, such as aircraft, satellites, foot soldiers, tanks and ships to find its target. The tactical Tomahawk can be reprogrammed in flight to attack one of 16 pre-designated targets, with GPS coordinates stored in its memory or to any other GPS coordinates. Also, the missile can send data about its status back to the commander. It entered service with the Navy in late 2004. Tomahawks are difficult to intercept due to their small size, small radar cross-section and low-altitude flight. The missile is launched and steered for the first few seconds of flight by a solid fuel booster with steering vanes in its exhaust. Then the stubby wings and control surfaces are deployed, and the turbofan engine takes over. Over water, the Tomahawk uses inertial guidance to follow a preset course. Once over land, terrain contour matching aids the inertial system. Terminal guidance is provided by the digital scene matching area correlation system, producing a claimed accuracy of about 10 metres. The Kosovo War in 1999 saw HMS Splendid become the first British submarine to fire the Tomahawk in anger. The Royal Navy later used them in the 2001 Afghanistan War and Operation Telic, the British contribution to the 2003 Iraq War. The new F-4U Corsair 1 became America's first 400-mile-an-hour fighter. Unfortunately, its performance caused questions over the Corsair's safety and led to it only being assigned to land-based operations initially. It was the units obtained by the British Fleet Air Arm that swayed the US Navy into re-evaluating and accepting the F-4U for their carriers. The English had a long history with aircraft carriers, and their opinions were well respected. Quickly, the British pilots came to truly appreciate the performance of their Corsairs. With some modification to the landing gear to reduce the bounce and the adoption of a curving approach on landing to maintain the pilot's visibility, the F-4Us went into operation. One other modification was required, removing 4 inches off each wing for storage, so as to fit below decks on the small English escort carriers. The American Marines, based at the newly acquired Henderson Field on Guadalcanal, had to fight stiff Japanese opposition to maintain their hold in the area. With battle damage, the primitive conditions and an unfinished airstrip, Henderson Field was soon littered with damaged aircraft. On the 12th of February, the Marines received their first F-4Us, and on the first day, most pilots logged over 9 hours in action. From the British results and the enthusiastic reviews of the Marines in the Pacific, the US Navy began retesting the F-4U in April 1944, and they were eventually cleared for carrier service. This proved timely as the Japanese war machine was now employing the desperate kamikaze operations, and the Corsair's power was sorely needed. During the course of the Pacific campaigns, the Corsairs maintained a loss ratio of over 11 to 1, an impressive legacy even by today's standards. The end of the war coincided with the crossroads in engine technologies. The new jet engines were in, and propellers were old hat. As a mark of their abilities, the Marines and Navy kept their F-4Us when most of the other models were simply scrapped. Comparing the planes of the day against the new Phantom, the Corsair was only 30 miles an hour slower, but had almost twice the range and could carry significantly more load. This would prove to be a wise choice, with the Korean Peninsula only a short period away. With their large load capacity and very accurate close in-ground support, the Corsairs tied up most of the Chinese transport and supply needs. The combination of American aircraft and their carriers gave the US and their allies virtual air supremacy. The Marines' efforts in Korea shine with the merits of the Corsair. The planes handled the extremely basic conditions on the matted strips with ease. The cold, though, was another matter. With the weather this extreme, the planes simply froze up. Even the Chinese could do little when it was this cold. As a mark of their worth, during the first 10 months of the war, the Corsairs flew 82% of the close-in tactical support missions. One squadron flew over 1,100 missions in a month. In English aircraft, this period also had a parallel development from their Hawker Typhoons and Tempests to their pinnacle, the Sea Furies. The climax of the line was the FB-11 Sea Fury, fitted with a Centaurus XV rotary engine outputting 2,550 horsepower. The Sea Fury was an outstanding aircraft, a tough customer in the attack role, but with light and responsive controls and excellent performance. While the F4U was built heavier to suit the thoughts of the time, the FB-11s were actually a lighter version of their Typhoon and Tempest forebears. These Hawker models used both inline and rotary engines and became very powerful, formidable aircraft. Today, few examples of these outstanding aircraft remain for the enthusiast to experience. Even fewer are in flying condition. Not surprisingly, both the Sea Fury and the Corsair have proven to be favourites with aircraft restorers. These Sea Furies were flown in Australia's island state of Tasmania in a recent air show and pylon race. The performance of these planes even today makes them an inspiring sight. Their classic shapes and throaty engines always draw large crowds in the hope of seeing a piece of classic aeronautic history. During the Korean War, there are a small number of reports of the two propeller planes attacking MiG-15 jets. One was of 8 MiGs trying to outturn 4 FB-11 Sea Furies. The result was a loss of 2 jets to the propeller-driven plane's cannons. 2 other MiGs were damaged, while the Sea Furies returned safely to their carrier. The era of a propeller fighter being launched from the rolling deck of an aircraft carrier continued up until the Vietnam War. They were superseded by the technological advances of the computer and the missile. The images seem to conjure romantic notions of sacrifice and honour, mixed strangely with the horror of war and the sadness of loss.